Welcome, everyone. Hope you are enjoying the final day of DevOps US. We are here to talk about CDI 2.0 and how you can use it in Java SE. My name is John Ament, member of the CDI 2 expert group. I'm an architect for Sparta Systems. I've worked on JMS in the past as well, Apache Delta Spike and ActiveMQ, and the Hammock project as well, which is doing microservices with CDI. So with the CDI 2.0 specification, it's the first time we're moving CDI beyond the EE realm, giving you the first chance to use it in your plain SE applications directly. Both implementations, OWB, Open Web Beans, and Weld supported a sort of SE mode that you could use. But now we've standardized on how to develop applications using CDI on Java SE. We always want user feedback. We want input from those out in the community who are working with it. So please go to cdispec.org, provide your input. We have the Jira issue tracker hosted by JBoss. We have mailing lists hosted by JBoss. Just everything is out in the open and free to use. All code is out on GitHub from the CDI specification, as well as the actual ASCII doc files that make up our text. If you want to grab the slides, they're hosted on my GitHub page, CDI-2.0 presentations. And there's currently a whole bunch of projects that actually support CDI in SE. Apache Delta Spike has a container control module that allows you to boot up the container. It was sort of the precursor to anything being available and gives you that backwards compatibility down to CDI 1.0 and 1.1. Apache Camel has also supported some form of CDI in an SE container. So you can actually run just plain Camel as a main application and get a fully functioning CDI container as a part of that. And allows you to bring in any Camel components that you may want to use, in addition to any beans that you're developing. Hammock is our first attempt at doing a pure CDI microservices framework. Pack CDI was one of the precursors to this, being able to use it in OSGI environments. So you can do some lightweight, either web-based or plain Java SE apps with it. MicroProfile as well supports it to some extent, with the fact that we're trying to move things into a more lightweight, consumable format. JBoss Weld and Apache Open Web Beans both support it as being the core implementations. There's never been anything blocking you from leveraging in either Weld or Open Web Beans. Weld has exposed a SE module for quite some time. And Open Web Beans has never really specified that you can only use it in the servlet container. And if you look at their core dependency injection, you're actually just bootstrapping it in a SE container. So what does it look like to start off with CDI in an SE world? It's literally 2 lines of code, creating a new instance of an SE container, and then initializing it. This will go through, find any managed beans that have, any bean archives that are on your class path with appropriate beans XML files, following either their annotated, all discovery, or none discovery to locate beans. It is auto-closable, so I am using it within a try with resources block. This gives you some basic, I can start it for the scope of a test and then tear it down later on, or start up a main method that just runs it in the background for you. It's really simple to bootstrap as a result. So what is the SE container from a CDI standpoint? It's a handle for your CDI runtime. It gives you a reference back to your CDI container for you to do bean resolution, as well as stopping the container and getting a reference to the bean manager. It is auto-closable. We wanted to make it very easy to use, especially within test cases. If you look at some of the core Weld test cases that just test Weld as a container, they're all doing try with resource blocks to have, within the scope of a single test method, a container that starts and then stops. It also has access to the bean manager. There is nothing stopping you from having multiple SE containers running at once, but as a result, you need to be able to differentiate the bean manager from container 1 and container 2. To do that, we have to give you direct access to the bean manager, which is our core entry point for CDI. It extends from instances. So This gives you some basic programmatic lookup within the container to find beans instead of having to go through the bean manager to do creation of context to bootstrap an application. And you can still use CDI.current in SE. So there's nothing blocking you from using what you're used to on the EE side to gain access to your CDI runtime. In fact, they're all extending from the same classes and give you the same functionality. You can reduce your class path as well, so you don't have to rely on properly defined beans XML files to go out and look at what beans should be discovered, what shouldn't be discovered. If I create a new container, adding packages, let's say bean.class is at the root of my application, I'm at com.foo.bar.bean class, I'm going to find everything child to that by recursively going through the package structure. This allows me to control what my runtime is going to look like and only pull in classes that I'm interested in for my application. It gives you a much lighter feel when working with a SE application. You don't have the heavy memory consumption that you might have in an EE world. And within the scope of this try with resource block, you would be able to look up programmatically any of these beans. You can also make it as configurable as you want. So you can do things like programmatically add extensions, decorators, alternatives, and stereotypes to your container. You don't have to rely on what's in Beans XML. You don't have to rely on what has been annotated to enable features or disable certain features. We also allow some amount of container-specific feature set. Doing things like add property over here would allow you to control weld-specific features around, executors for asynchronous event firing. You can instead point to your own custom properties as well. The other key thing around CDI in an SE environment is doing things around request management. So in certain SE applications, you might have a GUI that when you're clicking on a button, you want that to represent a request context. You may also be doing a TCP listener. As new traffic comes in through that request, you're able to start a context programmatically. One of the things we couldn't figure out, and we left it open, is whether context management should be a framework problem or a developer concern. Do you want to drive that based on your application logic? Do you want to drive that based on your framework's needs? So we added support for both. We allow you to programmatically start a request context through a built-in bean. In addition, we allow you to add it as an interceptor. So simply by going in through a managed bean that is annotated with activate request context, that will start and stop a request context through the method's invocation. Makes it very easy to work with and reduces the amount of boilerplate within your code. So we can inject a request context controller to do it programmatically. We start what we call the activate method to start the request context. This acts just like an HTTP request would in an EE environment. Any incoming code from here to whatever happens before deactivate would be within the bounds of a request context. If you later on, after this deactivate, activated another request context, you would get two discrete request contexts. Any beans created here would not be available for use after here as the same instances. You would get brand new instances for each of them. You do have to be mindful as to whether or not you are the one starting that request context. So if it's started at a higher level, you may need to you may not need to deactivate that request context as a result. You may inadvertently deactivate someone else's request context. And then the interceptor approach. It's much easier to follow because all you're doing is annotating a single bean method, saying within the scope of this method, I'm going to activate and deactivate a request context if it isn't already active. By doing this, you're alleviating yourself of a lot of the troubles around it and hiding the complexities of having to do things like checking to see if you're the one who started the context, Instead, that's all managed for you in CDI. We're keeping track of whether this invocation actually started a context or not. Another cool feature is around asynchronous events in SE. So especially with desktop applications as well as some lightweight server-based applications, you're going to want to do a lot of asynchronous processing. This can include things like publishing to a Kafka queue, handling user input, writing to a database asynchronously, and feeding that result back to the client. So to deal with that, we introduced the notion of asynchronous events. Because asynchronous events are inherently multi-threaded, those automatically gain access to a started request context. By starting that request context, the asynchronous observer is able to have a single bounds by itself of where it's processing the event. However, because we're in SE, we don't have that functionality with a synchronous event. So as a result, we have to build some amount of logic that's going to say, for a synchronous event, I want to have a request context active. So in this case, because I'm blocking, I'm operating within the same thread, I need to start a request context within the bounds of firing an event, simply to separate out what my event is doing from some other event that might be getting fired. So imagine that you had a sender method in some bean that all it did was fire some POJO object that could be application scoped or it could be input that the user entered in a screen. When we go through this sender method, any receiver that's going to observe that object will be bound within a shared request context so that you can share data between the different methods, but it won't go beyond the invocation of the sender method. It makes it so that you are able to use the same type of programming model that you would have used in EE, or even if you were doing an asynchronous event, instead in a synchronous fashion. So I want to do a short demo on how you can leverage this with tools like Netty. So I was able to put together a simple demo of how you would start a container using Netty, using my own main method to instantiate. Is everyone able to see that? So in here, all I'm doing is I'm starting an SE container, initializing it to discover everything that's on my class path. Because I'm doing that, I'm allowing everything to, by default, just occur the way you would be used to in CDI. There's no extra anything that I would have to do. If I wanted to, I can actually break this down and do something like add packages. And what this will do is only add the packages that are child to main, as well as main itself. So if I were to look at my project structure, you can see that all I really have in here are some 4 classes. So it's going to limit my discovery to these 4 classes, giving me full control over what is actually present within my container. So what I've done here is I've created a channel read handler, which is just responsible for handling anything incoming on my Netty server. Just going to be bound to, I'm actually not tying this to where it's being bound, but what I am saying is that a request context will be active anytime this method gets invoked for the channel read, allowing me to read that data and have a dedicated request context open for just iteration here. My time provider is a request scope bean, and because of that, every time I invoke this method, I'm getting a new time provider instantiated. So if there's any sort of state that I wanted to maintain within that HTTP request, I can by simply saving it in here. My time provider is very simple in that all it's doing is providing the current time in millis as a method call. When I'm coming in, all I'm doing is I'm printing out the current time as well as the data that was entered by the user. So I'm going to start a TCP listener on some port and expose that as a caller. And then the last part of this is a server initializer. There is no tie between the server initializer and my main class. I didn't have to do anything. However, what I can control from here is the observing of the application context being started on the CDI container. When I do that, I can have a post construct method or an observer method that will, on startup, start the server. So just as easily for this, I can do @post construct, and this method will be invoked before the observed method is actually invoked. If I wanted it started after, then I would uncomment that and instead allow the observer method to do the invocation of this server startup. I define a port that I'm going to bind to. This could come from a configuration setting if you wanted it to. So what I'll do is I'll go ahead and I'll start my container. Oh. Right. So anytime you're adding packages manually, you also have to disable discovery on your container, or else you're going to end up with duplicate beans defined. Okay, so my container started up, and now if I were to go telnet localhost 8765, and if I were to send over something like devox US is awesome, I'm going to see as output over here oh boy, there we are, that I was able to capture the time that that text was sent over as well as what the input was from the user. This is all tied into a CDI request context, allowing you to manage your state while not having to have any hard dependencies on any specific implementation. This is all straight CDI, starting from the SE container all the way down to any annotations that were defined on my beans. Because of that, you're getting a very easy to develop with framework without having to have a huge amount of dependencies. You're able to bring in as much as you need to manage it and work within what you consider to be your standard development frameworks. If I wanted to, I can do something like create a static int to keep track of my counter of number of times that this is getting invoked. Now, if I were to restart my application, we can see that each of the data sets that came over is incrementing the bean. It's always showing a brand new instance being created. So there is no hard dependency on anything EE here at this point. We were able to create a very simple TCP listener bound to a CDI request context, all pure CDI development, no external dependencies, no third-party libraries required to make this happen, which is a huge step up from where we have been. around CDI. Let's see. So another thing I want to just show you is how you can actually bind this within a servlet container as well. Obviously, I don't expect you to worry about all this boilerplate, but when I'm looking at something like Jetty as a servlet container, you now have the ability to go in and do things like add your servlet context. We're hoping at some point to be able to standardize how the integration to a servlet container works. So if you look, I've had to do things like override Jetty's decorator to say that it has CDI support, or have to go in and actually bind listeners to the context. There is no standard CDI listener, unfortunately, but I do hope at some point in the future, we do get to this where we're able to override and specify listeners to alleviate 100% of dependency on your container. So it gets you away from having to worry about using very container-specific logic to override things like how your CDI objects are managed, and instead moving towards a pure standard where now, even though this is Netty-based, all I've had to do was add logic here that started up Netty, and I'm good to go. This is just injecting a channel read handler, so I don't have to worry about where it's coming from. I just have them available to me. If I wanted to, I could actually replace this with an instance of them. And do stream for each be so I'm able to go through and find automatically through discovery any handlers that might be out there. What's the base interface here? Simply by relying on the channel inbound handler interface. If I were to start this back up, I can see that it's still picking up my handler automatically without having any direct dependencies on classes that I've built. So in a nutshell, that is CDI 2.0 in SE. Weld 3 is the reference implementation. It should be out as the final build sometime in April. We just passed through all public ballots. So we're hoping to get a lot of community input and see everyone start to use this a lot more. Be able to start moving some of what you've learned from working with EE technologies into more lightweight cloud applications. So we have a couple extra minutes. Any questions out there? Yes. So the question was, does it support JDK 9? Weld 3 has initial support for JDK 9. They did have to move some of their packages around to support JDK 9 in its most stringent fashions, but Weld does support it. And it will, I think officially Weld 3 will be the first release to support it. I think they've backported some of the fixes to 2.4, but because of the incompatibilities, it was limited in what they could do. Yes?
You said you're going to standardize the way you register with Servlet containers and stuff like that. Is it going to be part of the April release?
Is it going to be part of the
April GA release?
Okay, so the question was, we're looking to standardize the Servlet container registry. Is that part of the 2.0 April release? That is not. Currently, that's early discussions for CDI 2.1. Anything else? All right, well, thank you, everyone. Enjoy the rest of your DevOps.